All right, sound went down, means we're about to go ahead and get started. How was the sound? Is this okay? Or should I go a little bit higher? Is this good? Okay. My first silent disco. I've been in the audience, first time up front. I'm super excited. Thank you guys all for coming to the AWS Public Sector Summit. My name is Kwesi Edwards, and I am the Global Business Development Manager for our database migration program. It's called Database Freedom, as well as our database migration services, which is in the same team as our managed databases. I've been at AWS for about 3.5 years, which in AWS years is a very long time. And I'm based in San Francisco. So by way of agenda, we're going to cover these main areas when it comes to Amazon's RDS and Amazon Aurora. We're going to discuss performance and scalability, allowing you to have increased performance to meet the needs of your constituents. Availability and reliability, which is very important in terms of making sure that the data is available for use. Manageability is all about reducing the people effort, the human effort in the ongoing management and maintenance of those databases. Security, which is very important. Security is job zero at AWS. Security is very important in public sector. We take security very seriously. We'll talk about how you can make sure that your data is very secure in AWS. And finally, how to migrate. What are some steps you can take to get started on your migration journey, some tools and some activities. So if you walk away with anything, I'd like you to walk away with these 3 things. Choice, value, and innovation. Choice. There's a choice of engines associated with our managed database, and especially on our relational database side. There's a lot of value, ways that you can get a lot of value out of your managed databases. And innovation. We're consistently rolling out new features that you, our customers, have asked us for. But first, let's take a step back and talk about RDS. How many people are currently using RDS of any flavor today? Okay, so about half of you. So for the half of you that are already using it, you already get this, but just a quick refresher for everybody else. If you're managing databases on-premise, which the rest of you are, you or somebody within your organization is responsible for everything from power and cooling all the way up to the application optimization. People say, I want to get to the cloud. Well, there's a couple of ways to get to the cloud. If you come to AWS and bring your databases of whatever flavor, Oracle, SQL Server, Postgres, but install it on EC2 or your infrastructure as a service, then you're getting a lot of value out of our storage as a service, EBS, S3, and our compute service. So the OS installation and the server maintenance. There's a lot of value to that. But there's still a lot of undifferentiated heavy lifting that is your responsibility. Now enter our managed databases, whether it's Aurora or RDS, it's the same for this slide. We would then be providing the OS patches, the database install, the database patches, the backup, high availability strategy, and the ability to scale. A lot more of those activities so that you can focus on the value add for your internal and external customers, which has to do with the application optimization. There's still a role for the DBA in the cloud. Let's talk about Amazon RDS. Depending on how you count it, there's either 6 or 7 engines associated with RDS. What do I mean by that? Our cloud native engine is Aurora, but there's 2 flavors. There's Postgres and there's MySQL. But both are Aurora, and I'll talk about the benefits of Aurora. You can bring your open source databases or develop new open source databases on AWS by using RDS, Postgres, MySQL, as well as MariaDB. Many of you might be using some of the older commercial engine databases like Oracle and SQL Server. Our goal is to be the best place to run all of your database workloads. So if these are workloads that should run on a commercial engine database, they have the opportunity to run that in RDS as well and take advantage of the management associated with a database as a service. Automatic failover, backup, you just click a button and tell it how long you'd like to keep your backup. It's built into the architecture. Security, it's not a multi-tenant solution. You have isolation of your database. Industry compliances, as well as automated patching. A lot of customers I've talked to spend a lot of time with that patching process, so you can opt in or opt out of automatic patching. Either way, it's AWS and our automation that's doing that patching, not you. Advanced monitoring, and then push button scaling. So you can move from an instance this size to an instance that size and back down. That's really one of the key advantages of the AWS cloud in general is elasticity. We're bringing that down to the database layer, which many people have had challenges with scalability. Continuously innovating and bringing new features to market. These are features that you, our customers, have asked us for. We now support per second billing. This gives you a lot more granular control in the actual cost that you or the individual departments are incurring with those databases. More and more, we're seeing databases that are used for test and dev or used for some type of seasonal nature. When you need to spin those databases up and spin those down, I talked about that elasticity. Our pricing now down at per second really supports that, so you are truly only paying for what you use. RDS Oracle, MySQL, MariaDB, and Postgres increased their maximum storage size. They doubled it up to 64 terabytes and increased their I/O performance to 80,000 inputs and outputs per second. Why is that important? There were a lot of workloads that were sort of mixed workloads, analytic and transactional in the same database. And customers were seeing this large explosion of data. Maybe it wasn't big enough to fit into a Redshift or an EMR cluster or any of those other technologies. Still made sense for it to be relational, but was larger than traditional databases happen to be. By increasing that database, we can now support more workloads for RDS Oracle, RDS Postgres, etc. And then the increased performance allows you to meet some of the higher performance requirements that are out there. On SQL Server, a number of our customers told us they wanted the isolation of running a separate database, but the manageability of running it on a single instance. So we more than tripled the number of databases that are available in SQL Server. So now it's a maximum of 100 databases on a single instance. And then speaking of high availability, RDS SQL Server now supports the native SQL Server availability called always-on availability groups. So these are some of the recent releases within RDS that you, our customers, have been asking for. Enter Amazon Aurora. If you were to build a database today, we would build it very differently than the relational databases that were built 20, 30, almost 40 years ago now. It's designed to deliver the enterprise level capabilities, but at an open source price. So that's added speed and availability, similar to that of the commercial engines. Simplicity, cost effectiveness, as well as drop-in or wireline compatibility for Postgres and MySQL. Why is that important? Had a meeting with a consultant earlier today who said, well, we might want to deliver our project, and when the project's over, we want to get all the data out. How can we get all the data out if it's Aurora, if it's an Amazon database? The infrastructure and the optimization that we've done is all behind the scenes. To your clients, to your applications, it just looks like Postgres. So if at the end of the project you need to get the information out, it's just a PG dump. Or similar with MySQL, just a MySQL export, and you have the data out of Aurora if need be. And then obviously the simple pay-as-you-go down to the per second pricing that we just talked about. So reimagining the database for the cloud means increased performance, scalability, availability, and manageability. We've spoken about those things before. Now let's talk about how we actually deliver that. First is scalability. 5 times faster than open source MySQL and up to 3 times faster than the open source Postgres. If you take a look at this slide, what it's showing is our write throughput. So how much work can a MySQL database do? You're seeing a huge increase if you're looking at Aurora 5.6 or Aurora 5.7. And then on the read throughput, you move up from the 300,000 all the way up to 700,000. So this was using a standard Sysbench benchmark with 250 tables, 200,000 rows. We encourage you to run a similar benchmark yourselves. Because of this huge throughput, it works really, really well with high concurrent users. Does not mean that any one SQL query will necessarily run 5 times faster, but it can handle the scalability of lots and lots of concurrent users and do 5 times as much work in many cases. On the Postgres side, let's talk a little bit about bulk loads. Every database, traditional relational database, will have to do a copy in command, and then some type of vacuuming process where you're cleaning up and coalescing the rows that are out there, and then some building of indexes. With Postgres, the biggest time for loading data is around this vacuuming process where it's cleaning up after its writes. With Aurora, we're able to reduce that vacuuming process by 86%. And since that was the biggest chunk in there, you'll see how our loads are more than 2 times faster in Aurora as opposed to standard Postgres. So how do we achieve this? There's 3 things that we want to talk about. One is write only the logs and not the dirty pages. So there's less traffic, less I/O traffic. The next is let's do batch writes together. Instead of every single write creating an input-output operation, let's batch some of these writes up together. And then finally, let's offload as much processing as we can down to the intelligent storage. That's where the secret sauce of Aurora comes in, which is in the Aurora storage, and we're offloading a lot of the database operations down to the smart storage. Aurora Parallel Query. Very excited about this for analytic workloads. So the concept here is instead of just having a single place where the processing is doing, can we spread that work out, push the work of the query out, and then aggregate the return there? So it's a push down technology, do some parallel processing, you get rows 1 through 10, you get rows 10 through 20, you get the next 10. And then at the end, it's a parallel operation and return that information back. Netflix, the video streaming service, you might be familiar with them. They're seeing a lot faster performance, query performance. So to do the same work, they were able to drop down from a R3 8 extra large down to an R3 2 extra large, doing the same amount of work. So you can either look at it so that you can keep the same infrastructure and do X times as much work, or even lower your cost by having a smaller instance doing the same amount of work, which was the case for Netflix. So now let's talk about availability and reliability. It's designed for greater than 99.99% availability, and RPO is our recovery point objective of about a second, and our recovery time objective of less than a minute. So let's talk a little bit about availability. If you're using RDS, you might be used to this side, your left side. You have a primary database node and a standby database node. You have the elastic block storage, which is the storage underneath, and then the EBS mirror on one side. The standby node, or what we call multi-AZ, multiple availability zones, the multi-AZ solution is another database instance with its own storage. So it's a high availability solution, but it's also a bit of a disaster recovery solution within the same region, but across multi-AZ, you have duplication of all of the aspects of the database. Aurora, though, has very high availability, but achieves it differently. It uses all 3 availability zones for even higher availability and durability at the storage layer. So the separate read replica doesn't have its own data storage. It's part of a shared storage that's striped across 3 AZs. 2 different architectures, but the Aurora architecture is designed for even faster failover. As you can see, because of the way the synchronous and asynchronous writes happen on the RDS side, which is still very, very highly performant. We have a lot of customers running on RDS, but we're able to increase that performance and shorten that availability failover time with the Amazon RDS architecture. So, 6-way replication of storage. What that means is every piece of data in its own chunk resides 6 different places across 3 availability zones. And in order to do a write, you only need a quorum of 4 in order to do the write. Means you can return results faster, but also from an availability standpoint, you can lose 2 of those places where the data resides and still have 4 copies of that data to be very, very resilient and very, very durable. If you're doing a read, you only need 3 copies of those data. So you can lose, as you can see, you can lose an entire availability zone, but still have 3 copies of the data in order to continue to do your reads as well. So the ability to survive catastrophic failures within one region, we'll talk later about multiple region technologies as well. So, but this is logical. The volume is really striped across hundreds and hundreds of storage nodes. And you do not have to provision ahead of time. All of the provisioning is done in a dynamic fashion. Scalable read replicas. Both RDS and Aurora support the concept of read replicas. The value of a read replica is that you're offloading the compute from the querying times. So there may be some workloads that are read-only workloads that you can offload into a read replica and not take the performance away from your production or from your transactional node. So it relieves the pressure on the databases within one region, but we also now support cross-region read replicas. So you have a read replica in another region that you can bring your data closer to your constituents, and also as a high availability disaster recovery strategy as well. You can upgrade the read replicas to a new version, and as I said, it's supported for both Aurora and the RDS flavors. But the read replicas, as I showed you on the RDS side, have their own storage. Whereas on the Aurora side, since there's a shared storage, that read replica is near real time with your production database because it's sharing your storage. We've had a number of customers tell us that they didn't even realize that they had failed over to a read replica just because it was almost instantaneous because the storage was consistent across. You can have up to 15 read replicas on both RDS and Aurora. And also you can set up your failover. You can say, first try to failover to read replica 1, then 2, then 3, then 4. So there's a very granular control that you have across your read replicas. And very, very low latency, low lag. We're seeing less than 10 milliseconds lag in your environments there. So let's talk about instance and crash recovery from an availability standpoint. So traditional databases, you have to replay the logs since the last checkpoint. Checkpoint is where everything is consistent, and consistency is king within the database environment. And it's a single threaded operation in MySQL. So the amount of processing that it needs to takes a little bit extra time. What we've done, part of the things that made Aurora smarter is we were able to split those up, underlying redo records into separate disk areas. So there's no replay at startup. It's now a distributed operation, similar to our parallel querying technology, that instant crash recovery can happen in a parallel fashion, which means it's a lot faster to bring it back after the unfortunate event like a crash would happen. This is another technology that I'm very excited about. It's called database Backtrack. Let's say somebody does something to a database that you don't want to have happen. Accidentally dropped a table, changed some data, or you're planning to do a test where you're gonna do some testing on the database that you want to be able to go back to. This introduces the concept of a save point. You have the save point, then you can backtrack or you can roll back the database to that point in time. But it's not the same as a full database recovery where you've taken the entire database back to that point in time. That's a destructive operation. This is not a destructive operation. You can bring it back several times to that backtrack area and view the database as it existed at a previous point in time. So it protects against the unintentional DML and DDL. It's non-destructive and also very useful in Q&A. We'll have a lot of times where customers will say, not quite sure what had happened, and we're trying to dive in, maybe we're looking at logs, but in your QA environment, you may be making a number of changes to your database that you want to go back to see what the database looked like before because you were in a QA environment and making a number of changes. From a testing standpoint, QA is very, very exciting about Backtrack. We're also very excited about database cloning. It's really a fast cloning technology, a copy on write technology. So you take your production database and create near instantaneous a copy of it, because you're not copying any data. Only when you write and diverge from the original database structure does it actually do any write operations. So that clone can be created very, very quickly and destroyed very quickly if needed. We see a lot of customers that will have that core database that we're starting to put more and more in. One customer is telling us how all these other groups want to add additional schemas to their database so that it's all in one area for a true single source of truth. Well, the different developers of the different groups want their different copies to be able to make changes that don't affect the overall schema of that broad database. Enter fast database cloning. Can quickly have a database that your developers can work on and then only copy on write and then get rid of that database whenever needed. So we're scaling our write workloads, just so you understand. There's many ways to do conflict management. What we've done is we've done a very opportunistic way to do it, which requires less coordination, near linear scaling, and then lower commitment latencies. So more of the optimization of these open source databases to give you the types of performance and consistency that you're used to in commercial engine databases, but at 1/10 the cost. Global replication. Maybe it's just East Coast and West Coast US. Maybe it's not international, but know that the technology works from any region. So what we're doing is you have this concept of a read replica for both Aurora or RDS that can live in another region. That other region, people can be using the querying and accessing it really much closer to your constituents or your customers. But you can also promote that to a production transactional instance in the unlikely event of failure. So that's a disaster recovery solution as well. And for Aurora, we do support that across our 2 GovCloud regions on the east and on the west with Aurora today. Aurora Global Databases. It's another exciting technology. High throughput, right, up to 150,000 writes per second with very, very little performance impact. What it does is it allows for the processing in the standard Aurora infrastructure, but it has this replication fleet that's replicating to the other Aurora and another fleet. So you have these Aurora instances in multiple locations, but at the storage layer, you're keeping everything consistent. Thus the concept of a global Aurora database. And really, really fast recovery, less than a minute. To accept full write workloads after a region fails. So an entire region goes down, you're now accepting writes in another region in a minute. That's really, really fast. So let's talk a little about manageability. Those of you who are managing databases today might want to reduce the undifferentiated heavy lifting, reduce a lot of the manual effort associated with managing those databases. So let's talk about a few of these technologies. One is the Aurora Serverless. So instead of having to determine what the right size of your instance should be, just leverage serverless. What happens is it can shrink down to and even go to sleep for databases that are not being utilized very often. And then as you scale, it will automatically scale up for those environments. Applications with the variable workloads. So databases where maybe it's test dev or some reason people just aren't using it over the weekend, goes to sleep, cost gets reduced significantly, and then as you spin up, more and more instances can spin up as users increase. Dev tests, perfect for these types of use cases as well. And consolidated fleets of multi-tenant. So you may have multiple departments on a single tenant, and then depending on how you would like to grow, serverless is good for those SaaS use cases as well. So how are we doing this? So startup on demand and shuts down when not in use. So the application accessing the request layer, and then your scalable database capacity. How we accomplish that is we have this warm pool of instances ready to go. So if we need to swap in another instance that's higher, it's not a cold instance that comes in. That's why it's nearly invisible to you that we're doing that type of swap, because we have this warm pool of instances ready, and then we have the ability to shut down per second billing with a 1 minute minimum. So you actually do end up launching the database for 4 seconds. There's a minimum of a minute, but the way your processing should work, that will work out pretty well from what we've seen. So think of the Aurora Serverless as a technology where you do not have to right size your infrastructure. As your usage goes up, we can automatically scale up the usage of your instance and then automatically scale it down and lowering your cost there as well. Aurora Serverless, very exciting technology. Another technology I'm very excited about is called Performance Insights. It's a dashboard that's showing things like your database load. You want to see what type of bottlenecks that you have, how much your CPU is being utilized, at what point are you hitting some of your top SQL and your top sessions. You can identify some of the bottlenecks, so you can get in and kill that long-running instance, that one department that didn't know that they had this long-running query going on. You can see that. You can get alerts, and you can keep the data historically up to 7 days we provide for free. There's some costs associated if you keep it even longer, but we see people keep it for 2 years. Keep it even longer if you really want to see historic performance associated with your different databases there. It's a nice graphical user interface and allows, another thing that people have told us as they move from commercial engine databases is those databases came with these types of tooling and there wasn't these types of tooling and dashboards associated with a number of the open source databases. Now into Performance Insights, which works with Aurora today. RDS Data API. So as we're being aspirational, as we're making sure we're architecting for the future, we're thinking about all the different connected devices. I just think about all the connected devices I have in my house that's gone up exponentially over the past few years. You may have these smaller web interfaces for people that want to access information from these smaller devices. Now RDS has this API endpoint that could be put in front of your Aurora database. So you don't need a big fancy front end, it's just access to the data. So it's easier to develop for these other devices via the RDS API and have access that way. Okay. Let's transition into security. One of the first things we release is database activity monitoring. A number of customers told us that they were leveraging third-party tools to be the extra eyes and ears of their database, whether it's auditing super users, whether it is preventing certain types of activities from happening within the database, things that the DBA would be able to control. The most common use case was auditing and tracking those databases. Next thing we talked about is SQL Server Audit. So for those using SQL Server, SQL Server Audit was not available on RDS SQL Server. We've now made that SQL Server Audit available on the RDS SQL Server side. Encryption and security at rest. A number of customers were using additional high-price options for database encryption. Well, our databases can use our KMS encryption, RDS, and encrypt at the storage layer. But if you choose to use additional security like transparent data encryption that Oracle and SQL Server support, we support that as well. So across all engines, we have encryption at rest as well as encryption in transit. But if the engine does support additional security, we try to support that as well. Cross-region SSL copy, so you're sending a copy or a snapshot of the database from one region to another. We now support SSL to secure the data in transit, as well as the advanced auditing and logging without any performance impact. The one I'm really excited, of course, is the database activity monitoring, or we're calling database activity streams. So from Amazon Aurora, we can capture the streams. We've created this API that will share the information associated with the activity of that database, right? We can actually push it out through a Kinesis stream, and then wherever you'd like to surface it through. You can go directly into CloudWatch, and you can view it through Amazon CloudWatch. Or if you're using third-party products like IBM Guardium or Imperva, those, we can feed it into their repositories so you can analyze it there. We have a lot of people that like to use those tools for their auditors and for compliance reasons. We now support that as well. What you're seeing is more and more of these technologies and ecosystems associated with really mission critical databases that many people felt had to run on commercial engine databases. We're now applying that capability to our cloud native database engines. Each individual instance is firewalled off from the other instances. Lots of transparent encryption associated with it, SOC 3 compliance, ISO compliance, FedRAMP, HIPAA, things like VPCs, virtual private clouds. So you could actually have whitelists and blacklists of which IPs can access the database so that it's not just open to the broader internet. Lots of control there. And then lots of user management questions we've gotten, like identity and access management. We now support the plugins for identity and access management into our RDS and Aurora instances. So who's doing it? Lots of customers like the Veterans Administration, Ticketmaster, large companies, smaller companies. Lots of people are leveraging RDS. Let's talk about a few more specific ones, right? If we talk about Pearson in the digital learning space. So their vision is to have this direct relationship with their lifelong learners. And what they're finding is Amazon, Aurora, and RDS are really helping them deliver upon that mission. It's been a core part of their infrastructure to ensure they have the best performance, availability, scalability, and increase their users. They have the ability to lay down a foundation and grow as their user communities grow. They're also transforming their business into the digital and cloud areas. FINRA, in the financial space, the Financial Regulatory Agency, they've migrated over 500 relational databases from on-premise into RDS Postgres. That was their first step. Now they're moving to the next step of looking at Aurora to increase their performance and their availability. They are really giving individual developers a lot of freedom to innovate. And at the core of that is a lot of these innovators don't have to worry about the undifferentiated heavy lifting associated with the databases. We talked about the different ways to roll out test dev databases and other things. That really manifests itself in the ability to develop faster, develop new features for your customers, citizens, and constituents. Blackboard, really excited about this use case. They're the industry-leading learning management system. So many people in colleges and universities will use this learning management system. They released a version that migrated from Oracle over to RDS Postgres, and almost 100% of their users now have a high availability strategy. What they found is a smaller percentage of their users had a standby database because Oracle charged them to have a standby database. Once it became cost effective to have that, nearly 100% of their customers now have a standby database. But the value when you talk to the administrators is now the DBA can focus away from that day-to-day infrastructure work, that undifferentiated heavy lifting that we talked about. They manage some Oracle still, and the amount of databases they can do is much greater with less people when they leverage RDS and the automation associated with that. So they like the ability to quickly scale based upon demand and then move to newer, faster instance types really, really quickly. And near real time, they have a deeper level of control associated with their DBAs than they ever had before. And then finally, one last one is Arizona State University, ranked one of the top universities by US News and World Reports. Heavy reliance on a variety of databases, right? The distributed nature of their environment, people had developed multiple databases based upon whatever they decided they wanted to do. And they're able to move a lot of those databases now to Aurora and to RDS. So things like analytics, things like the data lake strategy, also around their Alexa side. And then they're really excited to see what they can now leverage with the Aurora Serverless side, because they have lots and lots of workloads, as you can imagine, with the cyclical nature of higher education, that will really scale up and then become almost idle at certain points in time. Okay, now let's talk about how to get there. So now that we've talked a little bit about the value of the managed databases, it's important to figure out, well, how would you like to get there? And there are multiple paths to there. We'll talk about just one. One is our database migration service and our schema conversion tool. Database migration service is a replication engine, a logical replication engine that will move data. And the schema conversion tool, as its name implies, can allow you to migrate the schema, the logical structures. You may hear the term database freedom. It's really freedom of choice. Freedom to choose the right database for the right workload. And because database migration service can replicate from one database engine to another database engine, you have a lot more freedom to build, not just build, but also replicate and modernize a lot of your database workloads. So what is this schema conversion tool? It goes out, logically looks at your database schema, Oracle, SQL Server, etc. And then it'll just do an assessment report and tell you how much of that database it can migrate to MySQL or to Postgres. You might find that you're not using a lot of database objects. And we have a numbering system called the Workload Qualification Framework. You might call it a WQF1, which means it's pretty standard SQL and it migrates very easily. You can migrate that database over pretty quickly. You might find that the database has lots and lots of objects that just don't convert very well. The schema conversion tool does convert stored procedures and triggers as well, but there may be some functions that don't map over very easily. First, it'll tell you that, and then it'll give you some recommendations on ways to remediate it. It might tell you that this is something that you can do really, really well, or you might need some of our partners. We have a very vast partner network, and we're calling our Database Freedom partners, which are partners that have public references of migrating from a commercial engine to an Aurora database. Once you have an empty schema, so once you have logical structures that you want your application to access, then you got to get the data in. That's where database migration service comes in. It can do the one-time migration and move the data in, and it can also do something called CDC, which is our change data capture, where it's capturing the changes on one database to the other. We see this a lot in a migration scenario, where you are migrating from one database, you have the new schema, but you just want to keep the two in sync for a week, 2 weeks, 3 weeks, whatever that is, before you cut over and point your database users to the new application. Once customers got wind of that, we're now seeing more and more customers doing ongoing replication with DMS as well, which it does support. So this is mostly a relational database conversation, but just to see from a source to a target, DMS supports the migration from any one of our sources to any one of our targets. So obviously things like Oracle and Postgres go really well into Aurora. But we're starting to see more and more things like Mongo and Cassandra going into DynamoDB, etc. As you look to modernize, there may be use cases where you're going to start pushing some of this data into Kinesis streams to do who knows what to. We see lots of ongoing replication between Oracle onto Redshift. Not to replace a full ETL tool, but if the source and target look pretty similar, an ongoing replication tool is very helpful for those types of scenarios as well. And then when all else fails, you can put it right into S3. Right? You can move your data into S3 and then pull it out in any number of ways from there. So a very versatile tool that allows you to first create the schemas that you want to migrate into, and then second, replicate data into it. There's a couple of things that we as your account team can do to help you get started. The first is to talk about these immersion days. So most of your account teams can deliver what we call an immersion day, where we map up our architects to your architects. We come in and spend some time with you on your use case and go much deeper into Aurora and into RDS. So you can look at ways to optimize there. You can also look at ways of doing things like hands-on labs in order to we bring some people that will help you do some hands-on playing with that. The slide I have up here usually comes after those first steps, and it's called a data lab. We're very excited about these data labs. You come in with an idea and leave with a solution. There's lots of things, including data lakes and predictive analytics and microservices that it can cover. There's lots of topics. We'll stay focused on the database migration aspect of data labs because that's the topic of today's conversation. I had one customer come in, they came in with an Oracle database. We ran the schema conversion tool and the database migration service, created the target. In this case, it was RDS Postgres. You could also do Aurora Postgres, and then move the data in. That took about 3 or 4 days. What's exciting is they stubbed their toe a couple of times, right? But what they told us is these things that took 2 hours, us looking over their shoulder, might have taken 2 months of just back and forth communication with the support. They also told us that it was nice to not have their day job hanging over them. So in this case, we brought them to Seattle, and it's great to have it in Seattle because all the different development teams are there, the data lab architects are working with you, and then we call in different members of the service teams of DMS or Aurora or other things to spend some time with you. Typically it's 3 to 4 days on site in Seattle, and then typically 4 to 8 developers. We do not want looky-loos. So we want the people that are actually helping to make this migration and make this migration happen. What's exciting is we just released the ability to do data labs here in the DC area. So that's an exciting additional piece. If you want to talk to your account teams, there is a process they will go through in order to be able to nominate you for the process of going through that data labs. So a good way to get started is some immersion days with your account teams, some hands-on labs, and then once you've identified the right project that's accomplishable in 3 to 4 days, not one that would take 3 to 4 months, obviously, get that first migration done, and you capture those learnings and bring it back with you. Typically, they're done in Seattle, but right now, we can do some in the DC area. Okay. So we think about Amazon RDS and Aurora. Lots of choice. From a engine standpoint, you have the ability to choose between Aurora for Postgres or MySQL, and then RDS, MySQL, MariaDB, as well as Postgres. And then the commercial engine databases. If it really is best to run in SQL Server or Oracle, we support that as well. Value. Lots and lots of new features, as you saw, that we're starting to roll out. Different instance types, better per second billing, increased security, increased capabilities that are built into that. And then newer innovations, new technologies that can scale up, higher performance, and a lot more value out of your managed database. So let's get started. So AWS, Amazon.com/Aurora. That's your site where you can get information about Aurora today. Your DMS slide. On the DMS side, there is a page, if you click on resources, that will give you these playbooks. If you're going to migrate Oracle to Postgres, it'll map the Oracle feature and the Postgres feature, or it'll map the SQL Server feature to the MySQL feature. It's a 300, 400 page recipe book, and it's available for free on the DMS page underneath the resources tab. And then obviously all the different flavors of RDS. And then take a look at this 10-minute tutorial on getting started. Get your hands dirty and start to move your applications forward. Okay. So with that, I really appreciate you spending time to understand RDS and Aurora. Please do leave your headsets on the slides, on your chairs, and fill out your survey. Feedback is always welcome. And we had a little bit of time, but I'm going to move out there. Myself and my colleagues will be outside to take a few questions as well at the end. Okay, thank you.